So we should rearrange this equation first. This equation has fractions in it. A friend of mine teaches junior high math, and she tells her students fractions are the F word. We need to get rid of these fractions. Fractions cause problems. The best way to get rid of fractions is to cross multiply. Cross multiplying is where you take the top of one side and the bottom of the other, and you multiply those, and you take the bottom and the top and you multiply those. So V1 times T2 is equal to T1 times V2. That's cross multiplying. The top, V1, times the bottom on the other side, T2. That equals the bottom of the first side times the top of the other side. And if you need help with that, please come talk to me. I can explain it more. Let's just remember what we're trying to find here. We're trying to find T1. Now this equation is much easier to rearrange. It's a lot like the Boyle's Law problem that we did. We just need to get rid of that V2, and we do that by dividing both sides by V2. The V2's cancel out. So we end up with T1 is equal to V1 T2 over V2. And we take our numbers and we plug them in. V1 is 2.8 liters. And T2, we have to use Kelvin, 273 Kelvin. And V2 is 2.57 liters. The liters cancel out. .8 times 273 divided by 2.57. Having issues here. I'm going to run this up to the top. I should have 3 sig figs, and so my calculation is saying that T1 equals 297 Kelvin. The question asks for the temperature in Kelvin and in Celsius. So that's the Kelvin temperature. To find the Celsius temperature, I'm going to subtract 273. So if I subtract 273, I get a Celsius temperature of 24 degrees Celsius. If we had used 0 Celsius in here, what would T1 end up being? 0. Is that the same as 24? No. And it wouldn't make any sense, would it? That the volume changed when the temperature was the same? It just doesn't work with Celsius. It just doesn't work. And the reason is that the conversion is involving adding and not multiplying or dividing. Any questions?